Welcome back, Math Minute number 45, chugging right along, getting close to the end of 2021. This may actually be the last Math Minute of 2021. I'm not sure what I'll get a chance to record before the end of the year. Thank you and welcome to all the new subscribers. There has been a winner selected for the headphones. I will say more about that shortly. If you have not been notified though, probably you are not the winner of the headphones. I'm sorry to say. But if that doesn't make you too angry, you can stick around and let's talk about exponentiation. So I did a video recently on, that other video platform, and I talked about how exponentiation is not repeated multiplication. The context of the video was trying to figure out what on earth is something like 0 to the 0. And I was saying that the only reason you'd really want to say that this expression is 0 is if the main way you understand exponentiation is to be repeated multiplication. I think it makes better sense, though, to look at 0 to the 0 in terms of a function, specifically the function where a variable raises itself to its own power, x to the x. And if we look at that function, at least moving from the right, and we let x get closer and closer to 0, what we're going to see is not that this approaches 0, but that it actually approaches 1. But why would that be? If this is strange to you, chances are you are thinking of exponentiation as simply repeated multiplication. And although exponentiation does give the same answer as repeated multiplication, that's not what it is. That's not what it's limited to. But of course, that raises the question, if exponentiation isn't just repeated multiplication, what is it? So I'm going to say something a little bit strange here. I'm going to contend that exponentiation is the operation that upgrades addition. It's an operation that takes an input of a sum and returns an output of a product. In function notation, f of a plus b is going to be equal to f of a times f of b. And that's it. Exponentiation is the operation that obeys this property. What could we say in general about operations that obey this property? Well, let's start with a particular sum, and obviously we want it to be as easy as possible so we can hopefully figure out what's going on here. Let's consider the sum f of 0 plus 0. Obviously, 0 plus 0 is 0, and so really what we see is that if we have some operation that obeys this property, f of 0 needs to be equal to f of 0 times itself, or of course what we typically call f of 0 squared. So now we have to think through, well, what kinds of numbers are equal to their own square? And it turns out there are only two answers to that question. 0 is equal to its own square, so we could say that f of 0 is equal to 0, but 1 is also equal to its own square, so we could say that f of 0 is equal to 1. Now let's set aside for a moment the question of which should we pick, 0 or 1. And let's explore some other possible values that a function obeying this property would return. Probably the next easiest sum to compute after 0 plus 0 would be 0 plus 1. So if we had a function that was obeying this property, f of 0 plus 1 should be equal to f of 0 times f of 1. But of course, f of 0 plus 1 is just the same thing as f of 1. 0 plus 1 is 1. So we need f of 1 to be equal to f of 0 times f of 1. Now at this point, remember, f of 0 could have been 0. And that would definitely make sense of this situation, but all it would mean is that not only is f of 0 equal to 0, but f of anything is equal to 0. So if we choose f of 0 equals 0, that's going to make our function awfully boring. All we're saying at that point is, if you have an operation that takes anything as an input and always returns 0, of course it could, technically speaking, turn addition into multiplication, because 0 plus 0 is the same thing as 0 times 0. But that's awfully boring. There's not much we could do with such an operation. So for that reason, it's going to make better sense to let f of 0 be equal to 1. And now we can see this is essentially just a statement of the multiplicative identity. Well, yeah, f of 1 is equal to f of 0 times f of 1, because f of 0 is just 1. Okay, so let's keep exploring. Instead of 0 plus 1, the next easiest sum is probably 1 plus 1. And if we have a function or operation that's obeying this property, f of 1 plus 1 needs to be equal to f of 1 times f of 1. Well, 1 plus 1 is 2, so what we're saying is that f of 2 is going to be equal to f of 1 times itself. And so now you can hopefully see the connection between just this property, a property that turns addition into multiplication, and exponentiation. So at this point, we can see the connection between at least whole number inputs and our typical exponential notation. We haven't actually decided on a value for f of 1. There is a most natural base to select, but I'm going to leave it for another video to talk about that. But if we just said in general, all right, f of 1 let's just say it's equal to some number n, then we could say f of x, generally speaking, is just going to equal n to the power of x. But there's nothing in this particular property that requires x be a whole number. We could let x be a fraction. We could let x be negative. We could let x be pi. As long as it obeys this property, it's exponentiation. But unlike our whole number inputs, if we let x be pi or root 2 or some other irrational number, there's no way to think about it in terms of repeated multiplication. Even sticking with things like negative integers, we're not really repeatedly multiplying by something. We're doing something else. Fundamentally, what that something else is requires a bit more rigorous definition than what I have time to do in today's Math Minute, but it's not difficult to establish that we are doing something different than just repeatedly multiplying numbers. When we say 9 to the 3 halves is the same thing as 27, we're not repeatedly multiplying by 9s. When we say 64 to the negative third power is 1 over 4, we're not repeatedly multiplying by 64s. And when we even compute expressions like root 2 to the root 2, we're definitely not multiplying root 2 times itself root 2 times. What exponentiation is something other than repeated multiplication. And one of my favorite answers you have right here, exponentiation is the operation that upgrades addition into multiplication. I hope that was helpful for you. Like and subscribe if so. Make sure to check out the other Math Minutes. There will be a button around here you can press for the Math Minute playlist. If there's something you'd like me to talk about or some question I didn't answer in this video, comment down below and let me know. And otherwise, I will see y'all next time.